So next we have kids your percent composition. So here we have a problem of your hydron carbons are organic compounds composed entirely of your hydrogen and carbon. A 0.1647 grams of your sample of pure hydrocarbon was burned in a CH or carbon hydrogen combustion train to produce 0.40931 of carbon dioxide and 0.20691 of your dihydrogen oxygen, your H2O or your water. Determine the masses of your carbon and hydrogen in the sample and the percentages of these elements in the carbon. So first, kita ang ginapangita natin ang masses of your carbon and your hydrogen. And in the sample index, you need to solve for their percentages man. So again, combine lang ni kung paano ito pangitaon natin mass and ang ato na percent composition. So step 1, ano ay pangitaon ta? Before ito makapangita sa percent composition, of course, yung ginhambal din nga, i-determine ta anay kung ano ang mass ni carbon and your hydrogen. To determine the mass of your hydrogen and oxygen, dapat isolve to siya as follows. Step 1. We use the observed mass of your carbon dioxide. Agad ang given yung mass of 0.4931. Areo, ginhatag sa ito ng 0.4931. It is the observed mass of your carbon dioxide. To determine the mass of carbon in the sample, there is 1 mole of carbon atom and 12.01 grams in each carbon dioxide. Therefore, 44.01 grams. We use this information to construct your unit factor. So this is its unit factor. Kids, din ko rin ako ang 12.01 and 44.01. So kids, to make it simple, ang atong carbon, amo na siya ang atomic mass unit nato na makita nato sa aton nga periodic table of elements. So carbon naton has an atomic mass unit of 12.01. And next, ang carbon dioxide naton is your molar mass na naman. Ang ginapakita is sa dalom. So it is your unit factor sa dalom. It is your molar mass or your molecular weight. So molar mass man siya or molecular weight. Because isa ka carbon is equivalent to 12.01. And ang aton nga oxygen, kids, kada molecule ya, may pila ka nga atomic mass unit, 16. So 16 times 2 is equals to 32 plus 12.01 is equals to 44.01. So it is your formula weight or your molecular weight or mass. Pamaya siya pagkuha ka. Next, step 2. Likewise, we can use the observed mass of your water, 0.691, to calculate the amount of hydrogen in the original sample. So we use the fact that there are 2 moles of hydrogen atoms in 2.016 grams, each mole of your H2O, 18.02 grams to construct the unit factor. Again, same na siya. Nga, ang gapita ka sa mass ni hydrogen. You are given, ari naman niya kids, ginhatag sa aton. To determine your hydrogen, to calculate the amount of your hydrogen in your original sample. So kids, for every hydrogen natin nga atom gani may hara ta 1.008. Or simply, pangitaon ta sa periodic table of elements ato ng hydrogen over your H2O nga molecule. Kids, duha ka hydrogen is equals to pila gani? One point. 1 times 2. 0.01 siya kids if i-round off natin. 1.01 times 2 is equal to 2.02. Hydrogen to niya. Kaya ganyan ang hydrogen ta is equals to 1. Round off tang 8 maging 0.1 na siya. Am I right? This is your hydrogen. Next, you have your oxygen na naman. Your oxygen, y siya sang subscript, therefore it is a constant of 1. So 1 times 16. Kung ko nakuha ang 16 again, it is the atomic mass unit. So 16 plus 2 is equals to 18. Carry over your 0.02 and you will have your atomic your formula weight of your H2O. So ara na sila nga duwa. Ara na si carbon, ara naman si hydrogen. Step 3, then we calculate the percentage by mass of each element in turn using the relationship of the percent of your element is equals to the mass of an element and the mass of the sample. Ang element nga ari di sa aton kids na ginhatag is your carbon and your hydrogen. First, we ang carbon naton ang ginhatag nga element and we have your element of hydrogen. Ara. Times 100. This is how you get your percent composition, right? So in this step 3, we calculate the percentage by mass of each element in turn using the relationship. So in the solution, pakita natin sa inyo kung paano nyo solve. Wait lang. So for your step 1, ang solvings natin are as follows. Sundon to ni. Ano ginhatagan sa aton na mass sa inyong step 1? You have your 0.4931 grams of your carbon dioxide. And you are finding your carbon, kids, nga mass. So therefore, butang ta, ang mass sa aton is 0.4931 grams of your carbon dioxide multiplied by 12.01 grams of your carbon. Again, din ko nakuha ng 12.01 sa periodic table of elements ng inyong carbon. Next, we divided it by your formula weight or your grams of the sample. Ang sample natin is carbon dioxide. Is it also your formula weight? Because ang carbon natin 12.01 tapos ang oxygen natin 32 plus mo sila maging 44.01. Cancel all like signs as usual. Tanan nga sa aras babaw nga kapariyo sa dalom, i-cancel naton. After sina, simply multiply and divide M-DAS law. Never forget it, kids. 0.4931 multiplied by 12.01 divided by 44.01 is equals now to 0.1346 grams of your carbon. Next, now that we have finished calculating the mass of your carbon, we now proceed to your hydrogen. So, in order to get your hydrogen, kids, tanong-tanong ang given nato na hydrocarbon. 0.1 and 0.2691 ang inyong nga water. And you are finding your hydrogen nga mass ato na water. So first, write the given of 0.2691. Ari siya ang 0.2691 sa problem. Salatan ni siya. 0.2691 grams of your H2O multiplied by 2.016 grams of your hydrogen. Ang 2.016 kids na kumandyapon simply in your periodic table of elements divided by 18.02 grams of our H2O. It is now equals to 0.03010 grams of our hydrogen. Now that we have finished your step 1 and step 2, meaning we have gained the mass of your carbon and your hydrogen, we now multiply it, we now divide it by 0.1647 grams of your sample of pure hydrocarbon, which was burned in carbon-hydrogen na combustion. 0.1647 ang inyo kids nga ara sa dalom. And you multiply it, kids, with your answer kagina sa babaw, which was your mass. So, kids, ang sabat na kon 0.1346 grams of carbon butang ko kay babaw, kay you are finding its percentage composition. Or its percent composition. 0.1346 grams of our carbon is the answer of your step 1. You divide it by 0.1647 grams of your sample, which was given above. It is your hydrocarbon. Right? You then multiply it by 100%. Then, to get your percent composition of 81.72% of your carbon. Next, ang hydrogen naman natin, kids. Ang hydrogen naman naton 0.03010 ang answer ta kagina siya mass ang hydrogen, right? You divide it by 0.1647 of our grams of our hydrocarbon or our sample. Multiply it also by 100 and you will get 18.28% of your hydrogen. To know if they are correct in your percent composition solving, simply add 81.72 and 18.28 in order for you to get your grand total of 100% in percent composition. So that will always be the correct answer. So it is step 1, step 2, and step 3. And that is how you solve your percent composition when we are dealing with its masses. And you need to also get its percent composition. So when the compound to be analyzed contains oxygen, the calculation of the amount or percentage of oxygen in the sample is somewhat different. Part of the oxygen goes to form your carbon dioxide and water comes from the sample and part comes from the oxygen stream supplied. For that reason, we cannot directly determine the amount of oxygen already in the sample. The approach is to analyze as we did in example 2.14 for all elements except only oxygen. Then we subtract the sum of their masses from the mass of the original sample to obtain the mass of your oxygen. The next example illustrates such calculations. So first, kids, we are looking at your example 2.15, your percent composition naman in another example. Next 2.15 is also an example of a percent composition. A 0.1014 gram sample of your purified glucose was burned in a CH combustion train to produce 0.1486 grams of our carbon dioxide and 0.609 grams of our water. An elemental analysis showed that glucose contains only carbon, hydrogen, and oxygen. Determine the masses of your carbon, hydrogen, and oxygen in the sample and the percentage of these elements. So kids, instead of duwalang ka-element kagina ang ara, which is carbon and hydrogen, subong niya sa ato na 2.15 tatlo na. So how do you do this kung tatlo na sila? Simple man yapon, the same steps apply. So yeah, okay? Step 1 and step 2, we first calculate the masses of your carbon and hydrogen as we did in 2.14. Step 3, the rest of the sample must be oxygen because glucose has been shown to contain only C, H, and O. So we subtract the masses of your carbon and hydrogen from the total mass of your sample. That's simple as that. In step 4, then we calculate the percentage by mass for each element. So step 1 and step 2, calculate natin ang masses ang aton carbon and hydrogen. Carbon and hydrogen, ari. Yung calculate natin, din ko nakuha si 0.14.86. Iyan ni carbon dioxide, 0.1486. Simply write it down below when you are writing for your carbon nga step 1. 0.1486 times 12.01, again, nakuha as predictable when divided by its formula weights and smaller mass or its grams of sample. I-divide na natin sila. Cancel all like signs as usual. Multiply, divide, and you will have your answer of 0.01455 grams of your carbon. Next, you have your hydrogen naman, kids. Ang hydrogen naman natin, dito ko si 0.0609. Again, sa problem yapon. Your water is simply your 0.0609 grams of water multiplied by its atomic weight of your hydrogen divided by the formula weight. Its combination of duwa ka H naton and our oxygen is 18.02 grams of your water. Again, cancel all like signs. Cancel all like signs. Multiply everything ara sa babaw. Divide it by everything ara sa dalaman. You will have your answer of 0.0681 grams of hydrogen. Step 3. And sa step 3 naman natin, kids, gin-subtract naman natin kay meron tas ang carbon, di ba, kag hydrogen. Have you remembered? So we subtract them, the masses of your carbon and hydrogen from the total mass of your glucose sample. Para ang bilin natin kag pangitaon ta lang is your oxygen. Okay? So 0.04055 grams of your carbon, ari siya, plus 0.0681 grams of your hydrogen minus the grams of your sample. Grams ang imong sample kids is 0.1014 grams imo na imong sample. I-minus mo na sa to get your total number. Amo ni sa step 3 naton. I-minus na lang ang aton yung sample sa inyo nga carbon and hydrogen in order for you to get your oxygen. Next, we simply find their percent composition. Ang yaka carbon 0.4055 divided by 0.1014 times 100 is equals to 39.99. Din ko din nakuha naman kids 0.4055 ara sa problem. Ara sa answer digili step 1 over 10.14 again it is your grams per sample. Next, you have 0.0681 sa step 2 naton. It is the answer divided by the given sample. Araman. And lastly, your oxygen. With step 3, gin-minus na lang si carbon and hydrogen kaya ang bilin natural si oxygen na lang. Divided by 0.1 ang 1014 grams times 100 is equals to 3.2. And you have your grand total of 99.9%. Again, there are sometimes, ibang instances nga you will have a 100.1 or 99.9% nga total nga answer. So, that is in acceptable range ang 99.10 kag 100.1 and is still considered correct. So, don't worry kung wala gid ka mo naga-chakto per me. Okay lang na kis amog 99.9 kag 100.1. Next, we have your determination of molecular formulas. Percent composition data yields only your simplest formulas. To determine the molecular formula for a molecular compound, both its empirical formula and its molecular weight must be known. Some methods for experimental determination of molecular weights are introduced in your chapters 12 and 14, but we will not get down deeper na tira. For many compounds, the molecular formula is a multiple of the simplest formula. Again, your molecular formula is a multiple of your simplest formula because your simplest formula is the simplest whole number ratio of your molecular formula. Therefore, kung malaba siya nga formula, it is your molecular formula, not your simplest or your other names ng simplest formula. It is your empirical formula. Consider butane, which has C4H10. The empirical formula for butane is C2H5, but the molecular formula contains twice as many atoms. That is the 2 times C2H5 is equals to C4H10. So, kita nyo, mas laba si molecular formula naton kaysa kay empirical formula naton. Benzene of C6H6 is another example. The simplest formula for your benzene is CH. But the molecular formula for your benzene is 6 times as many atoms that is of your CH or of your benzene. The molecular formula for a compound is either the same as or an integer or of multiple of them. It is the empirical formula. So your molecular formula is n times its simplest formula. Again, n describes your number or your integer. So we can write your molecular formula in n times your simplest formula weight, where n is equals to molecular weight divided by simplest formula weight. The molecular formula is then obtained by multiplying your empirical formula by the integer or your letter n nga small. So, para maintindihan nyo kids, we will solve na lang for your molecular formula in example 2.16, okay? Okay, again, ang molecular formula natin is a complicated process and a longer process than your empirical or simplest formula. In example 2.15, we found the elemental composition of glucose. Again, ang elemental composition sa ating glucose is C, H, and O, diba? Tapos, check yung percent yields as they are the equivalent of them. Other experiments showed that its molecular weight is approximately 180 atomic mass units. Determine the simplest formula and the molecular formula of your glucose. Step 1, we first use the masses of your C, H, and O found in example 2.15. Again, gamito natin ang aton nga C, H, and O that we found in your example 2.15, which is here. And then determine the simplest formula. Step 2, we can use the simplest formula to calculate the simplest formula weight because the molecular weight of glucose is known approximately at 180 atomic mass units. We can determine that the molecular formula by dividing the molecular weight by the simplest formula weight. So, muna nga formula atong gamitan kid. So, gamitan to dayan ang inyong stake. Example 2.15 to know your composition sa aton nga glucose. So first kids, we are basing our relative mass of elements to your table 2.15. CH and O has a relative mass of its element of yung carbon natin 0.04055, ang hydrogen 0.0681, and your oxygen is 0.0540. Now, is it correct? Yes. Next, you check their relative number of atoms. Again, ginhatag, check tanan niya relative number of atoms. Its relative number of atoms, pantagan and solve as given kagina. It is your relative mass divided by its atomic mass unit. So, ang atomic mass unit ng carbon is 12.01. Ang iya ka-hydrogen is simply 1 or 1.008 and your oxygen is 16. Again, check nyo depende kung magkano. Oxygen has 16 atomic mass unit, hydrogen has 1.008 and your carbon has 12. So are they correct? Yes. Simply divide them by the relative mass of an element and you will get the relative number of atoms. Ang relative number of atoms sa dayon. Next, divide them by the smallest nga number ng ara sa relative number of atoms. Sino si smallest? Si 0.3376. Siya ang pinakagamay nga number sa aton. So you should divide them by the smallest. So you now have the smallest whole number ratio after getting this. So your carbon has 1 carbon, ang hydrogen natin H2, and oxygen natin 1. So you now have the smallest whole number ratio. Anong brahon ta para may molecular formula sa next? Step 2, the simplest formula is CH2O. Ara nang yung simplest formula, which has a formula weight of 30.03 nga atomic mass units because the molecular weight of glucose is approximately 180 AMU. Paano ko nabalaan na 180 AMU ang iyaka glucose ko? Because in your problem, ginhatag ang aton na 180 AMU. That is why nabalaan natin nga si glucose may 180 nga atomic mass unit. We can determine then that the molecular formula by dividing the molecular weight by the empirical formula weight. So simply divide ang ginhatag sa aton nga formula molecular weight sa glucose divided by its empirical or simplest formula of 30.03. Ano? 30.03 AMU. Cancel all those like signs. Din lang ko. Cancel all those like signs and now you have a 6. Next, what do we do with the 6? The molecular weight is now 6 times the simplest formula. So, ang simplest formula natin kagina, ano ito ganigin ubrata? Ang simplest formula natin is CH2O2. So, CH2O2 is multiplied by 6. So, C H2 and your O. So, kung wala ni siya gani, kids ang subscript di sa kilid, it is understood as 1. So, 1 times 6 aton carbon is 6. Your hydrogen, 2 times 6 is equals to 12. And your oxygen, wala siyang sa subscript, therefore it is understood as 1 lang siyang element multiplied by 16. Ay, sorry. Sorry, kids. Sakto gali, sakto. Ang hydrogen natin may 12 na. And may 6 man siya. Talong ko. Na, sakto. Again, i-follow ta lang. Yung simplest formula. H2 ya 2 times 6. And your oxygen is now there for 6 man. Kaya again, din ko na po ang 6. It is here. Pag solve tas ang iyang step 2. Therefore, ang C naton maging C6. Right? Ang aton H2 maging H12. And your oxygen is now O6. Simply combine these three elements and it has now your C6H12O6. So the molecular formula of your glucose and the final answer is C6H12O6. And that will be all for our module. So again, kids, ginano ko lang sila when we are finding your molecular formula. Again, ginpangita ko lang ang smallest whole number ratio. Kaya may ara naman ta relative mass of your element. Again, ang duwangan ni Ari ni sa percent composition ng solvings. And we then divide them by the smallest in order to get your empirical formula, right? Your now empirical formula will be divided by 180 atomic mass units in order for you to have to gain your 6 nga muna. Tapos ang 6 nga ni kids ano natin ni siya kids? I-multiply ni siya natin sa aton na empirical formula given which is H2O2. So C1 multiplied by 6 is equal to C6. May C6 ta? May C6 ta di. Next, your hydrogen has a subscript of 2. Therefore, ang hydrogen ko duwa kabilog. 2 hydrogens multiplied by 6 is equals to 12. May 12 ko di, H12, right? May H12 di. Therefore, correct. Lastly, your oxygen. Kung wala subscript gagan, ano ganito sila kids understood as 1 na na. So, O, ang oxygen nato na 1, i-multiply taman siya by 6 as paano to digin solve man? And you have O6 and that will be how you get your molecular formula. So kids, that will be all for our module 7 and look forward for our final module, laboratory apparatuses. Amo na naging last module ta. It is gamay lang and hapos-hapos yung katama. Thank you for your time kids and have a good day. Wala na solving laboratory apparatuses ta ha.